Hello everyone, my name is Prerna Rawat and in today's session we are going to discuss about software engineering. So how this topic is important and why we are saying this is interesting topic as well. So software engineering, because you are a computer engineer, then definitely you will develop a software product. You will develop a software for a particular application. And when you are developing a software, then definitely you will think my software will be, according to user requirement, user will be satisfied with my software. Definitely you will want. At the same time, you want with minimum time and with minimum cost. Means I have to develop a software. So for that, basically we should have idea about the software engineering. That is the importance of software engineering, because everybody knows programming. If I am giving you a project with small information, you will develop the software. But if you want to develop the software, successfully based on completely user requirement with minimum time, with minimum cost, that means you should have idea about the software engineering. That's why this topic is important. And why it is interesting? Because right now so many applications you are developing related to real-time problem solving, like traffic management system, like route planning. You are enhancing the performance of GPS system so that you can reroute planning immediately. Am I right? Like space programming, so many space program are there right now running on. So you can give the instruction from the remote location and robot will perform the task. So that kind of application basically you are running right now. That's why it is very interesting, right? Netflix is there, online shopping platforms are there. Based on your interest, you can search everything. So that's why it is interesting topic. Now we will understand software engineering. So what is engineering? Because you are engineer. So first we will start from the engineering. Engineering means when you are solving real world problem by applying some mathematics, logic or principle of science. Right? That is engineering. Then software, when you are developing a software product by applying engineering principle, that is software engineering. So you can divide into two parts. Software that you are developing, and engineering means when you are solving real world problem or any problem by applying some mathematics or principle of science. That is engineering. So it is software engineering. One more topic we will discuss, that is SDLC, means software development life cycle. So in SDLC we will see the phases, we will see the different model. Right now you know the programming, right? But you don't know how we will develop a software, what kind of model we will choose to develop a software. So that idea we will get from the SDLC. So let's start the topic. Here is the content for today's discussion. First we will see the prerequisites, means what we should know before start software engineering. Then introduction, then SDLC cycle, importance of SDLC cycle, different module we will see the comparison as well, then some use cases and assignment based on today's discussion. So in prerequisite, you should know about the programming language, and I hope everybody knows about the Python and C++, because this is second year subject, and in first year already you have learned about the Python and C++. Here I am written only two, but if anybody knows about different language like Java also and other language also, that would be fine, because depends on the application. According to user requirement, you will choose the language, but you should have idea about the language. So these are some fundamentals for the language. If you are knowing any language, you should know about the variable, conditional statement, loops and functions. You should have idea before developing a software, because you will develop a software in software engineering. Now we will see the introduction part. So here you can see what is software engineering. Everybody knows the programming. If I am giving you a problem statement, you will solve it already, but you need a systematic approach, right, for developing a software. So software engineering gives you discipline, systematic and cost effective approach to develop a software. How? See with this example. First, what you will do, if you are getting a project, you will collect requirement, then you will form problem statement, then you will design, and after that you will do implementation and get the software product. So what you will do in the requirement, so you will suppose if I want to start a business, I want to sell the item on online platform, and for that I want application. So what I will do, I will think about the software developer, and I will connect with the software developer, and he will ask everything. What kind of software do you want? What kind of application do you want? What kind of items do you want to sell? So, and who will be the end user? All the questions software developer will ask to you. So this is a requirement phase, requirement gathering phase, information gathering phase. Then they will frame a problem statement. Okay, so that thing do you want? After that they will design and they will implement the software product. Okay. Now my question is, what software consists? Okay, so see the options and give the answer. And what will be the first step if you are talking about the software development life cycle? SDLC we will see, but I think you can give the answer based on previous discussion, like in the previous slide whatever we have discussed. So I hope you can give the answer. Just think about it. What will be the first step if you are getting a project? Now here are some small definition like software engineering. So it is a combination of two things, software product and engineering. So when you are developing a software product by applying some engineering application or principles, that is software engineering. Program is a small unit, means it is an executable code. Now here is your answer. What is software? Software is a collection of so many things: programmable code, associated libraries and documentations. Then software product, when you are developing a software for a specific purpose, that is software product. And last, engineering, means when you are solving real world problem by applying mathematics, by applying logics, that is engineering. Here you can see the software development life cycle, which contains 6 phases, and these phases are planning, requirement analysis, design, coding, testing and deployment and maintenance. So one by one we will discuss all the phases. As we discuss in the planning phase, when I will connect with the software developer, he will ask so many questions to me. What kind of application do you want? Who will be the end user? What is the purpose of your application? So this is the planning phase. He will get idea about each and every element of your product. Okay. Then they are collecting the information in the planning phase. After that, what they will do? Requirement analysis, means what will be the cost, how many people will work on that phase. Risk analysis they will perform, some security protocol they will frame. So they will ask everything, and after that they will prepare one document, that is software requirement specification document. That is important document, SRS document. So after finalizing all the requirement, they will prepare a one document and they will place it. Okay. Now in the design phase, they will prepare a one prototype. After requirement analysis, they will prepare a one prototype and they will discuss with the customer. Are you satisfied with this prototype or not? Means, do you want something else or that thing do you want? When customer agree or client agree, after that they will start implementation. So in the design phase, when the customer agree with the prototype, whatever they have prepared, they will prepare a DDS document, design documentation specification. Then they will do implementation. So here they will select the language and platform and they will start actual implementation. After implementation, they will perform testing. They will give the software to different team and they will test in different testing environment. They will find errors and they will correct it. Means they will get software development team will get back the software, correct it, send to the testing team, and this process is going on until the software is stable. Okay. Then deployment phase. So here what you will do, in deployment phase, basically your product is ready, you will give to the consumer, and at the same time your maintenance team will work. Means they will perform updation at periodic level. After some time they will prepare the updates, they will prepare the software, whatever they have prepared, the product, whatever product they have prepared, they will update. Like if you are purchasing the mobile, you will notice after some time you will get the update. So likewise they will work. Okay, so the maintenance work is going on to enhance the productivity. Now this is very important slide because here are so many models of SDLC. So first one is the waterfall model. Why these models are important? Because in which situation, in what environment, what kind of model we have to choose to develop a software. That's why we study these models. So classical waterfall model definitely we will not use, because here actually it is inflexible. If you start the project, you cannot change the requirement in between. That's why you will not use that model definitely. Then second one is iterative waterfall model. Iterative waterfall model is same like a classical waterfall model, but your requirement should be clear in the beginning. Then you can use that model, and you can provide the feedback also after every stage. Next one, prototype model. When customer is not clear, when customer and client is confused what they want, at that time you can use prototype model. You can prepare a prototype one by one. Once customer satisfied, you can start actual implementation, right? Then reusability is there, means whatever prototyping you are using, you can reuse again. So that is the advantage. Next one, incremental model. So there is no need to deliver the complete software. Module by module you can deliver. First module you can prepare, you can deliver it. Second module you can prepare, you can deliver it. But the disadvantage is that your requirement will be locked. Means you cannot change the requirement in between once your software development is start. Next, evolutionary model. In this model, it is same like an incremental model, but you can change your requirement after module. Means if your first module is prepared, you can change the requirement if you want in the second module. Rapid module, rapid application development, that is the RAD model. When customer have time and cost constraint, means if the customer want within a minimum time with a minimum cost, at that time you can choose RAD model. User interaction is too much in this model. Spiral model, when you perform risk analysis, right, at every stage, and that kind of things we will do in a complex task, in important task, in large project. So risk analysis is there at every stage. Then definitely it is not suitable for small. Otherwise your cost will be high, right? Agile model. It is maximum used by the users and software developer because it is advanced, it is flexible, and it work in a sprint mode. Means after you decide the timeline, you prepare the module. After that you will decide the timeline, you will prepare the next module, and everyone is working on the module. Like in a startup company, everyone is working on the module. After that they will discuss, they will share the idea, so they can enhance the productivity. Okay, so agile model, that's why in startup company maximum prefer. There is no hierarchy like team leader, project, software developer. In the agile module, everyone is same. Everyone is working on planning, everyone is working on the maintenance, everyone is working on the implementation phase. So this is a agile model. Now here is the question. Your software quality depends on what? Prevention cost, appraisal cost, or failure. This is true or false? And my second question, what details documents include? So think about it and give the answer. This is the importance of SDLC. Definitely, whatever we have discussed, you can understand. With the SDLC, we can enhance the quality, we can enhance the productivity, and we have a control at every stage of the software product. When we are starting the developing software product, at the time you have a control at each and every stage, right? So that is the best thing with the SDLC. And I have prepared one assignment. Please see, and if you have any doubt, if you have any question, please let me know. Thank you.